So yesterday's video that I was showing about the derivative of tangent, we were doing problem 23, sine over cosine is tangent. And we found that the derivative came out to be secant squared x, right? We were using the quotient rule to do that. Why were we doing the quotient rule? Well, we had a fraction here and we had one function in the numerator and a different function in the denominator. And so we're, going through the quotient rule and we end up with this fairly simple derivative. It's not a real complicated function. It's just secant squared x. But we might need to do some review, like what are these other four trig functions, right? Rather than just sine and cosine. Well, sine over cosine is the tangent function, or y over x. Remember how y in the unit circle is the sine and x is the cosine. Now I know we're using x for the angle as well here, so that could be a little confusing when I say those kind of words. But anyways, it's sine over cosine for the tangent, and for cotangent, it's the reciprocal of tangent. So you could have 1 over tangent here, but we often say cotangent is cosine over sine. And then cosecant, this is said cosecant of x is 1 over sine x, and secant of x is 1 over cosine of x. So on page 143, all of the rules are really neatly organized. So they use kind of a funny notation. They do something like the function, like the sine function's derivative. So they put a little prime symbol or a tick mark or an apostrophe up here. I don't know if that's the best thing to do, but man, it is sure more simple than putting like d of sine x dx, that differential notation. That stuff's a hassle. So I do kind of like it in its simplicity, like a little apostrophe. But if you get lost, like, what is this? It means the derivative of the sine function. We know that's the cosine function. And we just found that the derivative of the tangent function is secant squared. I haven't done the derivative of the secant function. I'd like to do that. But before I do that, let's get these all organized in our notes, okay? And I'm just looking at page 143 because I like how they have them organized. And what I want to do is I want to try to color code them the same way that I had this guy color coded right here. So in yellow is the derivative of the tangent, right? Okay. Now I'm just going to do one of these. I'm not going to do the other four trig functions, but let's do the derivative of the secant of x. So here's that differential notation I was talking about. D of secant of x with respect to x. Okay, so what am I doing? I'm going to take the derivative of 1 over cosine of x, all right, with respect to x. And, it is a quotient here, 1 over cosine, but I think I said the other day that, man, I'd like to avoid the quotient rule if I can, because it is a bit of a mess, So I'm going to do a chain rule, and I'm just going to raise the cosine function to the -1 power. Okay, so I'm ready to take the derivative now. The power rule says I bring the power down out front. So here comes the derivative now, -1 times the, let's see, what's the derivative? Oh, no. I got to first do the power rule with the inside function left alone, right? So the cosine of x to the -2 power, and then I take it times the derivative of the inside function. So that's negative sine of x, right? Well, there's a -1 here and a negative there, so those guys are going to cancel out. So I'm going to be left with the sine of x all over the cosine of x squared. You know how we sometimes put the 2 down by the s? So that's what I'm doing right here, the cosine squared of x. Now, why is it a +2 for an exponent? Because I moved it to the denominator. That's what the negative means, right? Move that to the denominator. Now, this guy right here could be written as the sine of x over cosine of x times 1 over cosine of x. And 1 over cosine is the secant function. And usually they put the secant function first. I don't know if there's a reason for that. I don't think there is. That you can write them in any order you want, but I always see it as secant tangent for the derivative. So I'm going to put that guy right there over here, and then this guy is the tangent function. So secant x, tangent x. I just proved that the derivative is secant x, tangent x, right here, secant x, tangent x, for the secant function, right? That's the derivative of the secant function. So look, I'm not going to do that for every one of these functions over here. It's all on page 143, right? But it might be wise for you to color code it like I'm doing in some way, in your notes. So for example, like what's the derivative of the cosine function, right? The derivative of the cosine function is negative sine. Maybe that's not one that we need to highlight, right? So let me change back to my pen and just put down negative sine of x. That we've known for maybe 3 weeks or something like that. The derivative of cosine is negative sine. But what we're talking about today is the derivative of cotangent. So what's the derivative of the cotangent function? Well, when I look at page 143, it says negative cosecant squared of x. So this is what I was talking about by highlighting it. So I've got kind of a different colored highlighter out there. Maybe you want to do something like this. I don't know how you organize your notes, but I don't know. Maybe that's helpful. Then the next one I'm going to do is the last one. And again, I'm just getting this from page 143. Okay. I'm not doing a proof for you. So I'm going to take the derivative of the cosecant function with respect to x. And that comes out to be negative cosecant x cotangent x. And you'll turn on your highlighter, or not turn on your highlighter, get your highlighter pen out. And maybe you'll highlight this guy a different color. All right. So maybe you see a pattern here. I do kind of like the way they organized it. See if you notice a little pattern in these guys, and it might help you remember what the derivative of each one of those is when you're on the AP test, right? You're going to have to know those when you're on the AP test. I don't want you to feel a ton of pressure right now to go and memorize them, but if you're good at memorizing things, go for it. But for now, for today, I just want you to look at page 143. There's going to be the chain rule involved in today's problem, so don't let that intimidate you. It's a good review of the chain rule. I know you can do it. Ask me for help if you want some help. I really care about you guys. I know you can do this. Thanks for watching my video.